Okay, so good evening everyone. I think many students are absent today because of the power cut. But anyway, we'll continue the class schedule. So last week I completed unit 3 chemistry, right? So the newcomers and those who missed the lessons, you have to get the recording and complete the work miss. And fourth lesson physics. So before fourth lesson, so we have done one more physics chapter under unit 2 motion in a straight line. That also physics. This is the second unit under physics in your grade 10 syllabus. So about Newton's laws of motion, right? So actually this Newton, so Isaac Newton is mostly linked with this force and the related phenomena. So one of the best examples is SI unit of force also measured in Newton. So there are three laws of motion under Newton's laws. So we're going to discuss all three laws plus practical applications of each law, right? So before we discuss Newton's laws of motion, let us discuss about some basic informations about force. Right. So you have learned under unit 2, force can be simply mentioned as a push or a pull, right? So force is a vector because it has a direction. Force is a vector. Vector means, so we had I'm not going to explain that in detail because we have done this under chapter 2 unit 2, right? Vectors and non-vectors. So vector means it has a definite direction as well as a magnitude. Therefore force also a vector. Example, your weight is acting towards the gravity, therefore your weight is a vector. But your mass, the total quantity of matter in your body, that is the mass of your body, that is measured in kilogram, and that is a non-vector. So therefore the mass and weight, there's a big difference, right? Okay, let's complete the first blank everyone. Force has a magnitude as well as a direction. Therefore it is a vector quantity. Complete the first blank everyone. Force has a magnitude as well as a particular direction. Magnitude as well as, if it is only with magnitude, we call it a non-vector. Full stop. Therefore, make T capital. Therefore, force is a vector quantity. Highlight the word vector. Vector. Force has a magnitude as well as a direction. Therefore, force is a vector quantity. Right. Next one. SI unit of force. So SI unit of force is Newton. That is capital N Newton. So you can write within bracket Newton. Remember in the exam when you are doing any calculation, if you have to find the force, so you have to write the answer in Newton. So whatever the force, frictional force or gravitational force or tension or upthrust or any type of force, gravitational force, magnetic force, so it should be measured in Newton, capital N. And there's a relationship between Newton and kilogram. 1 kilogram is equal to 10 Newton. That you have to remember. In other words, 1000 grams equal 10 Newton. 1 kilogram is 1000 grams. 1000 grams is equal to 10 Newton. That means 100 grams equal 1 Newton. So in the exam, you can get MCQs under this. Therefore, right, 1 kilogram is 1000 grams. So it's equal to 1 Newton. Therefore, 100 grams equal to 1 Newton. If 1000 grams equal 10 Newton, 100 grams equal 1 Newton. That also you should know. You better copy down both this. Right. So remember now students, so due to the power cut, I won't cancel the class. So the class will be scheduled as the usual time. So every Thursday 6 to 8, and you have to be well prepared at least to continue for about 2 hours the online class. You should have a device, or at least if one is not enough, you have to keep backup alternative one to continue the class, right? Okay, then number 2. So there are 20 lessons actually. Grade 10 out of the 20 lessons. So before the first term you have to complete 6 chapters out of 20 lessons, right? At least 6 lessons. So we are doing now, we can complete the work before, I think most of the government schools, they are not started even the grade 10 syllabus yet. And recently, I think last week only, they did the grade 9 term test, third term test. But anyway, you have to complete this work within this year, because they have extended the school time also until, I think, extra 1 hour extra time. Therefore, they will complete before this December. You have to complete all 20 lessons, right? Okay. Then next one, weight of an object is the force attracted towards the earth. So W for weight. And there's an equation which shows the relationship between weight and the mass of an object. It's W equals mg. Right? So you have to remember this equation for the calculation. W equals mg. W equals mg. Right. Right here, W equals mg. In front of W, right? So this equation, put 3 stars, is very important. You remember this for the calculation. So what is W here? W is weight. Weight measured in Newton. And M, right, mass of the object. So W is weight. M is the mass of the object. And G is gravitational acceleration. G is gravitational acceleration. Right. Then in right here, G, gravitational acceleration. Gravitational acceleration. G for gravitational acceleration. So you have to you can write there within bracket weight measured in Newton, mass measured in kilogram, gravitational acceleration in ms minus 2. So write weight measured in Newton, mass measured in kilogram, K simple, otherwise it becomes Kelvin gram, gravitational acceleration meters per square second, ms minus 2. So how to convert now? Example, imagine 1 kilogram you have to convert into Newton. I told 1 kilogram is equal to 10 Newton, but any amount of kilogram you can put here. This is in kilogram. So this is 10 ms minus 2, gravitational acceleration approximately 10. So you can put the amount of kilogram here. If it is 1 kilogram, 1 into 10, 10 Newton. Right? If it is 2 kilos, 2 into 10, 20 Newton. So this is the mass of the object in kilogram. This is gravitational acceleration, that is a constant. Gravitational acceleration of the earth is a constant, and it is measured in ms minus 2. This is also very important to understand. Let's see. Now weight measured in Newton, look at the screen everyone. Weight measured in Newton, capital N, right? Capital N. And mass of the object measured in kilogram. G, gravitational acceleration in ms minus 2. ms minus 2. So then what is the equation also you can see Newton is also equal to what? Kg ms minus 2. So that's what I have given here. Newton is also equal to kg ms minus 2 kilogram kg ms minus 2. Right. So this is the SI unit of force. This is the SI unit. This is the fundamental unit. Here the fundamental unit. Fundamental unit. Therefore, Newton is also equal to kg ms minus 2. Newton is also equal because once in the oral paper they ask what is the fundamental unit of the SI unit of force? What is the fundamental unit or the basic unit of the SI unit of force? So then the answer was kg ms minus 2. O level MCQ paper. So every year actually you don't get like a set up question from the grade 10 from the first few lessons. So mostly MCQs and the structured set up questions. So therefore you have to remember the units also. Actually in physics it's like memorizing part also, there are equations, there are units, there are calculation part there. So there's like to a certain extent you have to study and remember the equations and everything, and the other hand, so it's calculation, equation, units, graph. So most of the students they find the physics part bit difficult later, right, than biology and chemistry. Okay, so late comers, I think many students join late, so because maybe due to power cut and yeah. So we just started the lesson, so we are discussing about the fourth lesson, Newton's laws of motion. Before Newton's laws, you should know about the force. What are the things to remember about force? Force is a vector. Why force is a vector? Because it has a magnitude as well as a definite direction. And what is the SI unit of force? Capital N Newton. And 1 kilogram is also equal to 10 Newton. That means 1000 grams equal 10 Newton. Therefore 100 grams equal 1 Newton. So if it is 500 grams, 5 Newton. Like that, if you are given any amount of grams or kilograms, you should know how to convert that into Newton. So you can convert kilogram into Newton using this equation. You can write down this if you want. You can mark with the pencil to convert kilogram into Newton. So what is the use of this equation? Used to convert kilogram to Newton. Used to convert kilogram to Newton or Newton to kilogram. So either side you can, because G is constant. G is 10 ms minus 2. Gravitational acceleration is 10. That is a constant. It's given in the exam. Right. Then next one, what is the difference between the term mass and the weight of an object? So if you take, actually mass is the total quantity of matter in an object or a body, and it is a non-vector quantity. It has a definite direction as well as it is measured in kilogram. But if you take weight is a vector. It is measured in Newton, and weight is due to the gravitational attraction of the earth. Weight is due to the gravitational attraction of the earth. So right here the difference between the mass of, remember now the textbook also. Please raise the hand those who have got the textbook from the school. This chapter, I mean the fourth lesson, I mean the part 1 textbook. There are two parts, part 1 and part 2. Grade 10 textbook, those who have got the textbook from the school, please raise the hand. Right. So it's I think it's here the fourth lesson. This is the textbook, but if you want, you can download the textbook if you have not got from the school. You can go to the Educational Publication Department website, edupub.gov.lk website, or else you can write just textbook download. Education Publication Department website, you can download any textbook, the Sinhala, Tamil and English medium PDF. Now please raise the hand those who have not got the textbook from the school yet. then you can make a request or you can send the request, so I can forward the PDF, right? So until you get the textbook, you can use this PDF, right? Now there's a student join with device name, please leave and join with your first name and the name code, right? So because I am taking the attendance, please leave and join again, right? Right. So this is the fourth lesson. You can see the Newton's laws of motion they have given. So it's like force means it can be a push or a pull, right? It can be a push or a pull. And you can see in the page number in your textbook, page number, look at this screen everyone, it's here. Difference between mass and weight of an object. So here you can see the mass and the weight, the difference. So this is given in your textbook also, page number 95, right? In your textbook, page number 95, page 95. You can see the mass. What is the mass? The mass is the amount of matter in an object. So it is measured in kilogram. And the other hand, weight. Okay, this is very important. If you are even in the textbook, you can underline with the pencil or highlight. It's very important. Amount of matter, and the unit is unit of mass is kilogram. If you take the weight is measured in Newton, and so the mass is the amount of matter in an object and it is measured in kilogram, and weight is the force which attracted towards the earth. Weight is the force that the object is attracted towards the earth, and it is measured in Newton. It is measured in Newton. The other difference, weight is a vector, mass scalar quantity. Example, I'll give one of the best example. When you travel from the earth to the moon, right? So when you're on the moon, your mass won't change. When you travel from the earth to the moon, either you are on the moon or the earth, your mass will not change, but your weight will change. So your weight is less than that on the earth when you're on the moon. When you're on the moon, your weight will be less than that on the earth, because gravitational acceleration of the moon is less than on the earth, less than the earth. Therefore, you should know the difference, because most of the oral past papers within the first 5 MCQs, they give a MCQ about this mass and the weight, because many students think both these equal. Even in our day-to-day life, we call my weight is this much of kilogram. Actually, scientifically, if you analyze, it's wrong. So if you are telling my weight, you have to give the answer in Newton, right? Newton. And if you tell my mass of my body, then you have to give the answer in kilogram. So most of the time in our day-to-day life, we use the wrong unit for the weight. We tell weight is in kilogram. That is completely wrong. So I'll give one example. If you are 50 kilos, right? So if you imagine you are 50 kilos. So what is your weight? 500 Newton. How? 1 kilogram is equal to 10 Newton. 1 kilogram equal 10 Newton. Therefore 50 kilogram is 500 Newton. Or else you can use this equation. Can you see W equals mg? You can use the equation W equals mg and you can get the answer. So that's what they could ask under this, between the mass and the weight. So additional information other than the theoretic, anything else, so you have to copy down separately in your everyone should use a separate short note book or separate writing book, the additional notes. So that would be useful where oral science, oral exam they can ask, so which is not given in the textbook exactly, like they don't ask same thing given in the textbook as it is, so they will change, they'll make small changes and can answer the same concept. So how to convert this? Imagine if you are 50 kilos, how to convert this into weight? What is the equation? How to convert this into weight? Using the equation W equals mg. I gave that in the theory too. What is the equation? W equals mg. W equals mg. So this equation, all other paper is structured as your essay type questions. If they ask a question from this, sometimes they will allocate marks for the equation also. They will allocate about 1 mark for the equation and 1 mark for applying values, 1 mark for the final answer. Maximum like 3 marks they can allocate for this, minimum 2 marks. So how now what is your now 50 kilos? Now I want to convert this into Newton. How come? You put here 50 and G is 10. It's given in the exam. Gravitational acceleration of the earth is constant. So you multiply this by 10. So what is your weight now? 500 Newton. Answer is 500 Newton. Weight will be 500 Newton. Or else you can write, you can multiply kilogram by 10 to convert into Newton. If you only can put half kilo, but be careful in the exam, sometimes they can give the mass in grams. Don't put straight away 50 grams here. You have to convert grams into kilograms. That's very, very important. Most of the equations in physics, the mass you have to mention in kilogram, because what is the SI unit of measuring mass? Kilogram. What is the SI unit of mass? Kilogram. What is the SI unit of force? Newton. So therefore, you have to remember these things. So because these are the areas where they can raise questions in the term test papers as well as in the oral paper. Now remember, dear children, students, now from next month I am planning to start the paper class, right? So because theory class, 2 hours theory class is not enough to do the past papers, model papers, support seminar papers, provincial papers, and then practice the model. Yeah, so because it's not a exercise the textbook exercise. At the end of each theory tude I am giving some questions. Therefore, parallel to this, we will be having again 2 hours class, paper class. Most probably I am planning to start that from first week of May, the paper class, right? So most probably that will be Friday evening, 6 to 8, most probably Friday evening, right? So you have to keep that time free. You have to keep that time free. Either Friday evening or Saturday evening. I'll keep that. Right? Either Friday evening or Saturday evening. Right. Next one. I'll erase the screen. So we'll complete this in the theory tude. So about the mass and the weight. Right. So we are here now. Number 3. Explain the difference between the term mass and the weight. So highlight the word difference, highlight, mass, highlight, weight, highlight. Difference, highlight, mass and weight, highlight. So you can write one difference. What? Mass is the amount of matter of an object. Mass is the amount of matter. Amount of matter in an object. In an object or a body. While weight is the weight is the force. Weight is the force. I have given that here. Force attracted towards the earth. Weight is the force attracted towards the earth. Weight is a force attracted towards the earth. And one more thing you can write, mass measured in kilogram. SI unit of mass is kilogram and SI unit of force is, SI unit of mass is kilogram and SI unit of SI unit of weight is Newton. SI unit of weight is Newton. So you better copy down in point form, then it's easy to remember and study. So one difference, SI unit of the mass is the quantity of matter. Amount of matter you can highlight if you want. Amount of matter in an object called its mass, and the force attracted towards the earth is the gravity, that is called the weight. And SI unit of mass, kilogram, highlight here kilogram, mass highlight, kilogram highlight, K simple, otherwise it become Kelvin gram. Capital K Kelvin, be careful when you are writing the unit. Simple K, simple G. Capital K, simple G, Kelvin gram, not kilogram. If you write capital K, it's wrong unit. Capital KG, Kelvin gram. Or capital K meters, Kelvin meters, not kilometers. Kilo, kilogram, kilometer, K must be simple. Very, very important. This most of the students, they do this mistake even in the oral paper, right? So what is the SI unit of force is? SI unit of force is Newton. Capital N. But there's one more difference between these two. Right? Mass is a scalar quantity. Mass is a scalar quantity. And weight is a vector. Mass is a scalar quantity. And weight is a vector. Now I gave 3 points, 3 differences between these two. Why it's a vector? Because weight has a direction. Both has magnitude. Mass also you can measure in a definite value. So weight also you can have a value because both have in magnitude. You can express that using a value, but no direction for the mass, but weight has a direction. Right, highlight this word. This is vector highlight, weight highlight, vector highlight, mass highlight, scalar highlight. Right. Then if you want, you can write one more thing. Actually, your weight is independent of the your mass is independent of the gravitational acceleration. You can write here, the mass does not depend on the gravitational acceleration, or mass does not change with the place, but weight changes with the place. That's very important. Can you write that in your write book separately? In other words, mass is dependent on weight is dependent on gravitational acceleration, but mass is independent of the gravitational acceleration. You can write down this extra point in your writing book. You can write, mass does not change with the place. Mass of an object does, either you are on the moon or on the earth, your mass does not change. Mass of an object does not, unless you leave your body parts, unless you remove the parts of your body, your mass is constant, either you are on the moon or on the earth. Mass of an object does not change with the place, does not change with its position, does not change with the place, but weight changes with the place due to the gravitational acceleration. But weight changes with the place. Place means on the earth it's same, because same gravitational, because if the gravitational acceleration changes, only the weight changes, otherwise weight also will be same on the earth. Either you are on say in Colombo or Kandy, your weight is constant, but if you are moving away from the earth, then it might slightly change. Weight changes with the place. So you can write example. example, you can write weight of a man on the earth. Weight of a man of mass 50 kilogram on the earth. Weight of a man of 50 kilogram. On the earth is 500 Newton. So I will say 60 kilos. 60 kilos is 500 Newton. Because 600 Newton, sorry, 600 Newton. So the same man, same person, the weight of the man of 60 kilos on the moon. On the moon. It's a different value. It's different. So this is very important. This is a oral passive question I am telling MCQ. Repeated. They have asked this 3 times. Many students, they don't answer this properly. Right? Now, please highlight on the moon, on the earth, he is 600 Newton. On the moon, he will be less than 600 or more than 600. Definitely less than 600. The mass won't change. This here also 60 kilos. 60 kilos. Mass same, but weight changes. This is very, very important. Please copy down this. Everyone should maintain a separate CR book or writing book for the additional, example or extra point or the short note, because they can raise questions from these areas in the oral paper. That's why. So right here, what would be now? I'll take 100 Newton. I'll take 100 Newton. So let's say 100 Newton. 100 Newton. So the reason is this. You can write gravitational acceleration of the moon is 1/6 of the earth. That's the reason. How did you get this answer? Wait. I'll write here 600 into 1. So 600 Newton into 1/6. They will give in the exam this condition within bracket. They will give it gravitational acceleration of the moon is 1/6 of the earth. So I'll take here 600 Newton into 106. So that is 100 Newton. How come? Right within bracket here, gravitational acceleration of the moon is 1/6 of the earth. Gravitational. Why did I multiply this by 106? Because this weight decreased by 6 times. Gravitational acceleration, that means G. Gravitational acceleration of moon is 1/6 of the earth. 1/6 of the earth. Or else you can do this calculation this way also. Look at the screen, everyone. You can use the equation W equals mg. Right? W equals mg. So this is 60 kilos. So G will be what? 10 into 106. Then you will get the same answer, 600 Newton. Look at this, everyone. You can use this equation and do it. Look at this green, highlighted that green. 10 is the, G is 10, but on the moon it's 1/6 of the earth. On the moon it's 1/6 of the earth. So I'll write on the moon. So on the moon, the mass will be less than that on the earth. So this type of question they can ask in the oral paper. I will copy down. Everyone should maintain a separate CR book for physics to take down an example like this. Otherwise, no point of just copying down the same thing given in the textbook, because they will never ask you to write the same thing given in the textbook as it is. So that's why the last few years the science paper was harder than the maths paper, oral paper. And that this physics separate CR book for this additional notes, short notes, and you have to keep this until your O-level exam, right? Until next year O-level exam 2023 December, because you are getting physics questions separately, chemistry questions separately in the O-level paper. So imagine when the exam is closed, when you answer the any physics questions in the paper, when you practice the papers, so if you find it difficult to answer the physics part, then you can refer that short notebook or the separate book. But otherwise you have, like, you don't know, it takes long time to refer the notes and to find the note. So until O level, use the same writing book for physics. So don't write anything else there, only the notes like this additional note, right? Shall I erase this? Anyone still copying down this? So I gave now the difference between the mass and the weight. Under number 3 I gave this additional point. So under number 3 you have to copy down this extra point. Extra means you should know this, right? I mean, for your extra knowledge, but they can test this in the exam. They will give they'll give some other planet and ask. So if it is 1/5, 1/5 of the Earth, then you have to put here 1/5. This will say I'll put here 1/6. So this one, encircle one, you can change it depend on the planet. Right. Anyone still copy down? Please raise the hand. Shall I erase this? Now physics actually nothing much to write. I mean, not long paragraph like in biology, but so that concept, you have to get the concept. You have to understand the concept. So then you can manage any question given in the exam. Done? Okay, when you're done, please lower your hand. So again, if I quickly summarize what I told, force is a vector, force measured in Newton, and SI unit of force Newton, and the relationship between the force and the mass, W equals mg. 1 kilogram is equal to 10 Newton. And the mass measured in kilogram, and mass non-vector scalar quantity. Rashmina, when you are done, please lower your hand. We are waiting for you. Or else you can take a screenshot, right? Okay. Finish writing. Okay, next one, number 4. Different types of forces. Okay, who can suggest some now forces of different types in our day-to-day life? Right? Even a push can be a push, or a pull can be considered as a force. What are the other type of forces in our day-to-day life? Pulling force or pushing force. Any other forces? Yes. Any volunteers? Number 4. Different types of forces. So I'll write here pulling force. They have given in the textbook also at the beginning. See here in your textbook, the first page. So you can see here this is push in a table. So that is a force. And then this is push in a bus. Now these days the many people are not pushing the bus or even vehicle must be, but other than that, barriers, right? Okay, with the police officers. Yeah, often any idea? So what are the other type of forces? Yes.
Frictional force,
Very good.
gravitational force,
Correct.
electrical force, magnetic force.
Good.
Yeah, that's it.
Yeah. Okay. Very good. Very good, Afan. Okay. Good try. Now, okay, let's write them. So first we'll write the ones given in the textbook first. The pulling force. Or just write a pull. Or pushing. Then gravitational force. Then frictional force. In addition that, you can write, if you take an object floating on water or in air, so then there's a upward force acting on, maybe a balloon floats on air, there's a upward force acting on the balloon, or else a boat or a ship floating in the sea, so there's a upward force acting on the object floating on water, maybe a rubber ball even. So that upward force acting on the object floating in a fluid called upthrust. Upthrust. What is that? Upthrust. So all these are what? Remember, in the exam they can give a question like this: which of the following physical quantity measured in Newton? They can give any of this. They will not give directly force. They will give upthrust. Which of the following is a force? Which of the following is a type of force? Which of the following physical quantity is measured in Newton? So instead of giving directly force, they can give upthrust. They can, yeah. So even they can give, there's something like, okay, who can tell me if you are this is a pull, right? This is a push, and this is a pull. Now, what is when you stretch the rubber band? When you stretch the rubber band, there's a force exerted. What is this force on the rubber band called? Who, anyone can? When you are stretching the rubber band, there's a force exerted on the rubber band. What is that force called? Yes. If you are stretching a rubber band, or if you hang an object on the ceiling of the slab using a thread or rubber, so the weight of this acting down, and there's a force acting on the, what is this force called? Weight of the object acting downwards towards the gravity, and upwards on the thread or the string, there's a force. Yes, Kishan, what is that force called?
Tension.
Very good, Kishan. Yeah, that is called tension. Very good, excellent. Tension, that is also a force. Tension is a force. So right here, number 6, tension. So as Afan also gave some example, they also correct. You can write if you want many few more. So magnetic force. Magnetic force. Even you can write here electrical force or electromotive force. Electromotive. Right. Now that's enough. So these are the different type of force. Why do we apply a force? Why do we apply a force? So there are many reasons for applying a force. For example, if you want to move something, maybe a cupboard or table, or maybe the ball, or vehicle, or any object. So if you want to move an object at rest, you have to apply a force, and that force must be unbalanced. If you want to move an object, you have to apply a force, and that force must be unbalanced. That means if the forces are balanced, the object, just because of applying a force, the object will not move. I'll give one example. You are if you apply a force forward on this object, 10 Newton, then your friend is applying in the opposite direction, 10 Newton. Now there are forces acting on this, but this object will not move. Why? Because forces get balanced. Or else you can write tug of war. You are pulling this side, also you are pulling this with the same force, 20-20. So this will not move either side. This will be at rest. This will be at rest. Why? Forces are balanced. Forces are at equilibrium. If forces are balanced, then the object is at rest. Therefore, forces must be to move the object. In order to move, forces must be what? Unbalanced. Forces must be unbalanced. It's very, very important. Please note down this in your separately in your short notebook. So what is actually the force here? The net force, so we call it resultant force. What is the resultant force here? Resultant force 0. Resultant force is 0. Therefore, the object is at actually no force. Resultant force means 20 and 20 get cancelled. So the opposite. So just because of applying a force, you can't tell object is moving. So it should be unbalanced force. That means if the towards left side the force is greater than towards the right side, then yes, that can happen. Is that clear? Shall I write this diagram? If you make the, okay, how can I make this unbalanced? Imagine a situation like this. You apply this side 20 Newton. You pull this towards the left side with 20, and then towards the right side you apply with 15. Now what? Forces are unbalanced. Now it will move. Here it will move. It's moving. Here it is at rest. See the difference? So if forces are balanced, object is at rest. If forces are balanced, object is at rest. If forces are unbalanced, object is moving. If forces are unbalanced, object is moving. Therefore, in order to move an object, the forces must be unbalanced. That's very, very important. To move, the forces must be unbalanced. Here you can write the forces are balanced. You can copy it on both these diagrams. First diagram, forces are balanced, unbalanced. Forces are unbalanced. Therefore, the object is moving towards the greater force. Therefore, object is moving towards which side? Towards the greater force. It is moving towards the greater force. Towards this side. It's moving towards the greater force. Forces are unbalanced. Therefore, object is moving towards the greater force. Object is moving towards the greater force. Therefore, object is moving towards the greater force. Are you all copying down this separately? Not in the tute. You have to copy down these two in your writing book. Please raise the hand, those who are still copying down this. Those who are still writing, please raise the hand. Unbalanced word important. And balanced word important. Here unbalance. Here balance. Balance and unbalance. Done? Okay, I'll erase the screen. If I was writing, please raise the hand. Okay, I'll erase the screen. Now let's see what changes. Forces can have the following effects on an object. One effect you can write. An object at rest can be moved. An object at rest can be moved. An object at rest or a body at rest can be moved. Objects or an object at rest can be moved by applying a force. So you hit the ball or you kick the ball. So the other one, moving object can be brought to rest. Moving object, after you apply brake, that is a force. Moving object can be brought to rest. You can make the object, moving object can be brought to the rest, as well as object at rest can be moved or can stop the motion of an object. Or you can write here, can stop the motion of an object, can stop the motion of object. Right. Then what else? You can change the direction of the moving object. Example, rugby, football, cricket. So the ball is sending the leather ball towards the wicket. Batsman change the direction of the ball. Batsman hits the ball. Then the direction of the ball changes. Direction of the ball changes. So you can change the direction of the moving object. By applying a force, you can change changing of the direction of changing of the direction of moving object, changing of the direction of moving object, change in the direction of moving object. Right, change in the direction of moving object. What else? You can change the velocity of moving object, can change the velocity or the speed of moving object, changing of the velocity, direction you can change, velocity can change in of the velocity, or you can write the speed, of moving object. Example, you accelerate the vehicle. Accelerate means you apply greater force from the engine. When you accelerate the vehicle, the speed of the vehicle increase or velocity of the vehicle increase. Can you highlight here the important points under this? Say you can write direction you can change, and can move the object, can to the rest, and can change the velocity. Velocity can be moved. You can make an object to move from rest. In addition to that, you can changing of anything else that we can do with by applying a force on an object. Changing of velocity can be increase or decrease. Velocity can be increase or decrease. Yes,
Sir, we can change the shape of an object.
very good, excellent, very good. Yeah, can change the shape of an object. Very good. Example, a sponge or maybe clay. So you apply a force and change its changing of the shape of an object. Anything else we can changing of the shape of an object. So if you hammer it to a metal, so it's you can change the shape of the maybe jewelry industry. You can hand over a ring and ask to make a bracelet or anything, earring. Changing of the shape of an object. Highlight the word shape. Anything else? Anything else we can change the body of or an object by applying a force? So I'll highlight here shape of the object. Yes. What about if you take a rubber band or something, or coil or spring, and if you pull from both the ends, whatever, the length will change. Changing of the length of an object. Changing of the length of an object. So sometimes you can get MCQ in the oral paper. Which of the following cannot be done by applying a force on an object? By applying a force on an object, which of the following cannot be done? So they'll give 3 of this and 1 incorrect answer. They can ask MCQ. Once in the oral paper they have asked. Changing of the length of an object. You can change the length. Example, right? Stretching rubber band. Changing of the length of an object. Right. So I gave now 6 changes that can be done by applying a force on an object. Right. Next one. Please raise the hand. Those are still writing. Shall I read this? Anyone still writing? Please raise the hand. How many of you have got the printout of this tute? Please raise the hand. Those who have got the printout of this tute. How many of you have got the hard copy of this? Last week only I posted this to your WhatsApp. So you had nearly 1 week, right? So if not, you have to copy down everything in your writing book. Right, nearly 10 students. Right. So the others, you better copy down, put the page number and write number 5 and write, because it's your choice. If you want, you can complete the note. This will be your theory note. So I'll give you long paragraph like that. So in point form you can copy down. So this will be your theory note, because not only for this year, so until you finish your O-level exam in December next year, you need these notes to revise this again later. Right. Shall I erase the screen now? Okay, done, right? Okay. Then next part, number 6. When there's no external unbalanced force, very important, highlight the word no external unbalanced force. No external unbalanced force acting on the object. So acting on an object at rest. So if you are not applying any force, now imagine there's an object at rest. So no unbalanced external force. Forces can be applied, it's balanced. Unbalanced word is very important. Again, I'll underline that also. That unbalanced word is very important. Now also, are there forces acting on your body? Please raise the hand. Those who are saying, yes sir, there are forces acting on my body now. Please raise the hand those who are getting a force at this moment. If you are getting a force on your body. Yes, that is gravitational force, right? That is gravitational force. Correct. So even now, but you are not moving some. So you are sitting on you are lying on the bed or sitting on your chair, because forces are balanced. Even though forces are acting on your body, they are balanced. And the resultant net effect is 0. Net effect 0. That's why you are at rest. So therefore, until you make them unbalanced, if the chair, the one leg is broken, or then you will become unbalanced. The forces become unbalanced. Then you will face an accident. Right. So unbalanced force is acting on an object at rest. It remains stationary. It remains at rest. It remains at rest or stationary. Next one. When there's no unbalanced external force acting on an object which is moving. Right. Something is moving with the same speed. At rest, object at rest remains at rest. Object at rest when there's no unbalance. So I'll highlight here. Object at rest remains at rest until you make the forces unbalanced. If it is at rest, it will remain rest. And the other one, if there's no unbalanced force acting on an object which is in motion, no unbalanced force acting on the object which is moving now. Previous one at rest. What is the difference between the previous one and this one? Previous one at rest. Now this one is moving, but the forces are balanced. It moves with same speed or uniform velocity. It moves with uniform velocity with the same speed. Moves with uniform or constant. So you can write it moves with same speed or same velocity. This is very important to understand. That means objects tend to continue what they are doing at this moment. So imagine now our life also like that. So when you are used to do something, you don't like to change it. So imagine the technique or whatever the way you brush your teeth, every day you use the same method. So if you are going to somewhere and used to sit in your classroom somewhere, you can imagine from the first day until the last day of the school in that class. If you are in one classroom until for about 1 year, every day you go and sit at the same place. So you don't like to change it. Right? So therefore, if something is at rest, it tends to stay at rest. If something is moving, it tends to move with the same speed or same velocity. these are the two facts of the Newton's first law. If you can put a curly bracket for number 6 and 7, the two main facts of the Newton. So if you combine these two, that will become the Newton's first law. So you can put a curly bracket for 6 and 7, right? Two main facts of the Newton's first law. Two main facts of Newton's first law. Two main facts of Newton's first law. Newton's first law. What are the two main facts of the Newton's first law? FACTS. Until an unbalanced force is applied, bodies at rest remains at rest, and bodies in motion continue to move at uniform velocity. But actually, practically, it's a bit impossible that second one. If you are not applying a force, it will not pay, because example, you start the vehicle and then drive the vehicle at in the highway at 100 kilometers per hour, and you stop applying force from the engine. You make the engine neutral. So then will the vehicle travel until goal with the same speed? Then no need to burn any fuel. So it's like you start the vehicle and give the same speed 100 kilometers per hour, and you remove the forces applied from the engine or wherever. But it will slow down and come to rest. It will not travel with the same speed forever. Why? Because of the air resistance, because of the friction between the tires and the road. So there are many barriers. So therefore, in real life, it's very difficult to move an object. But there are some. I'll give one example. A helicopter. A soldier jumped from a helicopter. Or soldier jump from a helicopter, and what happened now? The soldier will float in air for some time, and it will reach to the steady velocity. You can search in the internet what happened when a soldier jump from the helicopter. Whatever, the parachute also can get open. When the parachute get open, they slow down and come to steady velocity. When the soldier reach the steady velocity, forces are balanced. Then no unbalanced force. So then he will reach towards the earth or the ground with the same speed. So that is, at the beginning he is moving fast. So when the parachute get open, then forces get balanced and he will travel with the same speed. That is something similar to the second fact. Okay, now let's write the Newton's first law. So you have to remember this. There are three laws. So this is the first law, right? Until an unbalanced force is applied. So actually we combine the first and the second fact. Until an unbalanced force is applied, until an unbalanced force is applied, comma, bodies at rest remain stationary. And bodies in motion, or the objects in motion, continue to move at uniform velocities. Bodies in motion continue to move at uniform velocity. Right. So So what is Newton? So please highlight the important terms here. Look at the screen, everyone. At rest, body is at rest, remains stationary. And the other most important thing, body is in motion, move at uniform velocity. Body is at rest, remain stationary. Body is in motion, travel at the same speed. Until when? Until you make the forces unbalanced. Until you make the forces unbalanced, object at rest. Don't memorize word by word this definition. If you are trying to do that for the whole syllabus, all 9 subjects, you will be ended up in the mental hospital. Many students, they complain, sir, I memorize, I study, I forget. Yes, obviously you forget. If you memorize everything you learn, then that's also a problem. Right, so you'll forget, with time you'll forget. But my advice, try to understand this concept, and you should be able to use the same set of words here which gives the same meaning in the exam. Otherwise they will never check in the exam. It's all these words given in the correct order in the exam by all the students. No. So you can use this in different, you can change the place and you can write it using your own words but without missing the keywords. At rest, objects at rest remains at rest. Objects in motion continue to move with the same speed or the same velocity until an unbalanced. So if you only can start from the end, you answer, or else you can start from the beginning. So therefore highlight what? At rest will be at rest, or in motion will be in motion with the same speed. Yeah, Afan, any question?
Yes, sir. So what happens if we apply an balance force? Will the body in motion stop moving?
No. If you apply a balance force, okay, you ask, so when it's moving, you apply a balance force. Actually, if you apply balance force, it will move with the same speed. Afan, I think, can you repeat the question again?
Yes, sir. So if an unbalanced force is applied, the body moves in an uniform velocity. Then what happens if a balanced force
Yes,
is
yeah,
applied?
correct. Yeah. So good question. A good question. When it is moving is the same. When it is moving, you apply unbalanced force. Then it will slow down and come to rest. It will slow down and come to rest. Often. I'll give one of the best example. Now imagine you drive the vehicle highway. When you drive your vehicle at 100 kilometers per hour, right? So while now you apply 100 kilometers per hour, the forces are balanced. Then you suddenly make the forces unbalanced. Unbalanced means you apply brake. Unbalanced means apply brake. What will happen? When you apply brake, what happen? It will slow down and come to rest. You apply additional force backwards, so that is brake. So when an object is moving at the same speed, that means forces are balanced. So if you make the forces unbalanced, it will slow down and come to rest. You got the answer, the answer for your question, right? Afan, did you get the answer, or is that clear?
Yes, sir. Clear.
Right. Okay, so remember, you can put 3 stars for this. They can ask in the exam, write down the Newton's first law, because that's why I have highlighted this. I told you there are 3 laws of motion by Sir Isaac Newton. That's why we call it Newton's laws, Newton ge niyama. So actually, if I tell, like, practical in our day-to-day life, so whether he's living or non-living, they don't like to change their current position. In other words, that is the now example after example, the students, those who are very lazy to study, it is very difficult to get them back to study. When they start studying, they will continue. Difficult to stop them. When someone get addicted to do something, maybe smoking or consumption of liquor, or maybe get addicted to to sugar or ice cream, or it's like greediness also an addiction, right? Greediness also addiction for various things. Then they'll end up with diabetes. So then they can't stop eating that. They can't stop doing that. So it's very difficult to change. So example, now you are used to sleep after your meal, then it's very difficult to stop that. So when you start doing something, very difficult to change it. So if it is a good thing, you can continue, that's okay. But if it is a bad habit, it's very difficult to change it. A lot of effort, a lot of energy required, right, to change it. That's why even I'll give another example. Private sector, for most of the jobs they get the school leavers, because it's very difficult to change their mindset. Like, mindset is easy, but after getting the graduates, very difficult to change their attitude and the mind sometimes. Therefore they don't prefer, and because then they demand more salary also. That's the other problem. The school leavers, so they can get done more work the way they want, and they can less salary sometimes, and the training, right? So then they can according to their needs, and they can change the person. Okay. At rest remains at rest, in motion will continue with the same speed. That's what the Newton's first law, right? It's not hard. Try to understand the concept. And next one, I'll erase the screen. Then Newton's second law. So that's about the Newton's first law, right? Okay. There's no calculations. They will not ask any calculations from the Newton's first law, but Newton's second law, you are getting calculation and the equation also there, right? Newton's first law, like, qualitatively, but they can ask sometimes small practical question related to our day-to-day life. Okay, now next page top, page number 2 top. Newton's second law. Okay, this Newton's first law and second law, you have to remember in the exam. If they ask write down the Newton's second law, you should know how to write, because therefore 3 stars, you have to remember this. You have to memorize 2 laws. Now Newton's second law is this actually. Okay, before you write, okay, no, forget about the law. Let's see. It's about the relationship between Newton's second law of motion is about force and the acceleration. The relationship between force and the acceleration. It's about the relationship between what? Force and the acceleration. Between the force and the acceleration. Between force and acceleration. Okay, let me explain like this. Okay, if you want to copy that, if you want to write down this within bracket, it's about the relationship between the force and the acceleration and the mass. Force, acceleration, and you can write all three. Relationship between force, acceleration, and mass. Force, mass, and acceleration. Relationship between force, mass, and acceleration. The relationship between force, mass, and acceleration. Right. Let's see what happens now. If you increase the force, what happens? Force increase. Then what will happen to the acceleration? Acceleration will increase. That means it will travel at higher velocity. Acceleration also will increase. That means, I'll give one of the best example. If there's a trolley, the ones in you are supposed to do this in the school as a practical. You pull this with one rubber band. The trolley, one rubber band. So instead of one rubber band, now you pull this with the 2 rubber bands. 2 rubber bands. Now here F, this is 2F. It's like 2F. That means force double. So what will happen now? The second trolley will travel greater distance than the first trolley. and it will, so this is, you can copy down this in your writing book or here itself. Right here one rubber band, this one right, two rubber bands. Please note down this everyone in your writing book or here itself. This is a trolley, this is also the trolley, the similar, two similar trolleys, and here you put rubber band, you stretch the rubber band, you pull to a same, when you extend the, you pull the rubber band to a certain extent, and to the same extent you pull the other trolley also with two rubber bands. Here one rubber band, here two rubber bands. When you use two rubber bands, force double. Force double. When the force double, what happened? Acceleration also will be double. So that means force is directly proportional to the acceleration. Or else you can write acceleration is directly proportional to the force. When the acceleration double, force also double. That's what it means. So how to write the directly proportional? This is a mathematical expression. So that means what? When the acceleration increase, when the force increase, acceleration also increase. That's called directly proportional. That's called directly proportional. This is very, very important. Can you all please so acceleration, or you can write here, acceleration of the trolley increases with the force. Acceleration of the trolley increases with the force. Acceleration of the trolley, acceleration of the trolley increases with the force. There's a practical given in the textbook also on this. I'll show that after this. Increases with the force applied. With the force applied on it. Done? Is that clear? So if you make 3 rubber bands, then the force increase by 3 times. So imagine instead of one person is pulling the table and two of them are two similar, like with the same force. You and your friend is pulling the force. So then it will travel with higher speed, right? So obviously it's common sense. Now shall I erase this? Okay, I will show this in your textbook also, page number 88 in your textbook. Okay, let me show you that one. Did anyone still copy down this? Please raise the hand. Okay, let me show that in the textbook also. Okay, we show you are copied down. Okay, wait. You can take a screenshot even, or you can quickly finish it here. When you're done, lower your hand. Right. Now, let me show that in the textbook. Sansala also copied down. Okay, what is Newton's first law? It's about, I will relate this with your Newton's laws and the motion graph also. Okay, wait. When you are done, Sansala, you have to lower your hand, or else you can take a screenshot. Right, done. Okay, let me show that in the textbook. Take right here itself, right? Practical of the activity example, right? Experiment, activity. Refer activity. Activity 4.6 in the textbook. You can write here itself. Refer the activity in page textbook page 88. Here also, because when you study the tutor, you can refer that. No? Textbook page 88. Page 88. Okay, I'll show that now. If you have got the textbook, you can turn the pages. Page number 88. Check in your textbook. Page 88 has given this. Under Newton's second law. This one, can you see here? So the experiment, to please highlight and put 3 stars near this. Very, very important. Most of the Western Province term test papers, they have asked this. 3 stars for this. Very, very important. Experiment to verify what? Newton's second law. So can you all see the screen now? What is this? This is only one rubber band. Here you have what? Two rubber bands. So hold the free end of the rubber band with one hand and the trolley with the other hand, and you have to extend. You have to pull to the both. You pull to the same extent until the end of the trolley. So both the trolleys move with acceleration, but the second trolley move with greater acceleration. It will travel greater distance. So the second trolley will move with the observation. The second trolley will move with higher acceleration, with higher speed. So you can repeat this with 3 rubber bands or 4 rubber bands. So what is the conclusion? Acceleration of the trolley increases the force. Right. So that's what they have given here. That's the practical. This practical is very important. It's very easy, like a very simple experiment. Page number 88. That's what I explained earlier. Now if you want, you can do this also. You can with the same trolley, you can put a weight on this iron block, extra weight, and then you apply the same force with the trolley. You pull the trolley and you pull the rubber band and release it. You pull the rubber band and release it. Then it will move forward. So what happens now? When the mass increases, acceleration will decrease. So that is the relationship between the mass and the acceleration. First one I showed you 1 rubber band and 2 rubber bands. Why? With the increase of the force, how acceleration changes. Why 1 rubber band, 2 rubber band, 3 rubber bands, like that. To show that force is increasing. Then the acceleration also will be increasing. That is called directly proportional. But now what I am doing, no change of the number of rubber bands. First you repeat with 1 rubber band and then you repeat the experiment with, by putting extra weight on the trolley. By putting extra weight, extra mass on the trolley, you repeat the experiment. Then you will notice it's like this. You asked to run the 100 meters race keeping someone on your back. Mass increase, then you can run fast. So definitely it will be more difficult. So it will slow down. My acceleration will be less. Is that clear? So you run the same race by keeping someone on your back. So then the mass increases, acceleration decreases. What are the 2 factors affecting the acceleration now? Unbalanced force will affect the acceleration and mass of the object will affect the acceleration. Other than that, the condition of the surface also matters. If you ask to run on a slippery surface, or if you ask to run on a very smooth surface, when you ask to run on a rough surface, so is that also with the nature of the surface also will affect, and the air resistance and the type of clothes that you are wearing. Let's say swimming and water polo, or even 100 meters race. What, you're not running with a jacket and helmet and all this stuff, caps and heavy clothes, because more air resistance. So there's a disturbance from air when you're running. To minimize that disturbance, you have to wear minimum clothes when you're running 100 meters race or even in swimming event. In addition to that, there's a resistance from water also. Air resistance, water resistance, resistance between the friction between the sole of your shoes and the road or whatever the track. All this matters. Therefore, what are now here we are going to discuss about the 2 main factors that affect the acceleration is mass of the object and the unbalanced force applied on the object. So higher the force, higher the acceleration, greater the mass, lower the acceleration. That is called inversely proportional. One is directly proportional to the acceleration, that is force, and the other one is inversely proportional to the acceleration, that is the mass of the object. This is the Newton's second law. That's it. What is Newton's second law? When the force increase, acceleration increase. So we write force is directly proportional to the acceleration. The second, that is the first fact. Second fact is acceleration, force, and the acceleration, acceleration is inversely proportional to the mass. So we are right here, A is directly proportional to force and A is inversely proportional to the mass. 1 over m. 1 over m is what? When the mass increases, acceleration decreases. What is the first one? When the force increases, acceleration increases. So what are the two main facts of the Newton's second law? Number one is this. Number two is this. Sometimes they will ask you to write in the exam not the Newton's second law. They will ask you to write down the two main facts of the Newton's second law. Then the first fact will be what? Acceleration is directly proportional to the force. That is the first one. Second fact will be acceleration is inversely proportional to the mass. So this is what, if you want to write this mathematical expression like this, or you can write the same thing in words. First one is directly proportional, the other one is inversely proportional. What? Acceleration and force, here the acceleration and the mass. So no need to memorize. If you can directly absorb this and keep in your head, that's it. If you study this once before the exam, that's enough. But the problem is many students, the weakest point, many students when someone explain the concept, they are in an imaginary world or they engage with some other activity. But when the teachers start reading the note, they nicely copy down. Very neat handwriting. So when the parents check their writing book, everything, every day he has done the work and everything perfectly done. But when the teacher explain the concept in the classroom or wherever, physical or online, they are doing some other work. When they start giving the note, they copy down. But at the end, they don't know what they have copied down. They can understand their own notes. This is the main problematic situation. So therefore, when you have to be both physically and mentally with the lesson, right? Otherwise, in vain that time. So you are just like a clerk copying down the notes. So that's why many students, sometimes the parents complain. So he came to all the classes, he didn't miss, and he copied down all the notes and everything done, but no marks in the exam. Marks not expected now. So less marks in the term for the term test. Right? That's the main reason. So you have to be an active learner. The other most important thing, you should learn how to learn. Learn to learn. Right? That's the other thing we should teach the students. Learn to learn. Right. Okay. We'll write the Newton's second law now. You all got it, the Newton's second law, right? So not just to memorize the definition, you should know what is the meaning of that definition. What is the meaning of that definition? Right. Write the Newton's second law. Acceleration of a body is directly proportional. The acceleration of a body is directly proportional to whom? Acceleration is directly proportional to the unbalanced external force. Not just, unbalanced very important, not just force, because when you apply force, then the other side also there's a force. Then what happens? Forces are balanced. 10 cancel out. Is there any acceleration? Acceleration will be 0. Object is at rest. Remember, that's why we have to mention unbalanced force. Acceleration is directly proportional to the unbalanced external force. Unbalanced force acting on it. And it is inversely proportional. Inversely proportional. INVERSCLY. Inversely proportional to the mass of the object. Inversely proportional to the mass. So please highlight what is the, there are two main facts of the Newton's second law, like same as the first law. What is the first fact? Acceleration directly proportional to the force. That is number one. Second one, acceleration inversely proportional to the mass. Inversely proportional to the mass. Second fact. If you can copy this in your writing book separately, the two main facts of the Newton's second law. Directly proportional to the force, inversely proportional to the mass. Directly proportional to the force, inversely proportional to the mass. How to write this mathematical? What is the mathematical expression for this? Look at here. I have given here acceleration. This is the directly proportional sign. Directly proportional to the force. And acceleration is inversely proportional. How to write the inversely proportional? Acceleration is inversely proportional to the mass. Inversely proportional to the mass. Directly proportional to force, inversely proportional to the mass. Right. So you can combine both this. So these are the two main facts of the Newton's second law. If you want in the exam, you can write the mathematical expression also, no problem. Instead of writing in words, you can write this way also. What is two main facts of the Newton's second law. Newton's second law. Two main facts of Newton's second law. But when you change the mass, force should be constant. Otherwise, example now, imagine you run first without without keeping anyone on your back. Then second time when you are running with someone else keeping on your back, so then you can't run fast. Acceleration will be less. So best example, any vehicle that's accelerate, right? When you accelerate the vehicle, that means more force. So the vehicle is moving fast. That is the first one. But when the vehicle is loaded lorry, so when climbing a mountain, it's like very difficult. Right? More effort. So these are the two main facts of the Newton. So the what you wrote in words, so I have given here also separately. So when you combine both these, you can write like this. You can combine both 1 and 2 like this. Both 1 and 2 you can combine and write like this. Acceleration is directly proportional to force and inversely proportional to mass from 2 and 3. So I'll highlight this. Both 1 and 2 you can combine and write like this. F over m. F directly proportional, m inversely proportional. That means when the force increase, acceleration also increase. When the mass increase, acceleration decrease. Red one both upwards, blue one when m up, a is down. That's what it means. In the exam don't write like that, just to understand. Right, so that rubber band thing also very important. The truth trolleys, so that the experiment given in your textbook. Actually, the syllabus they are going to change now. I think you all are doing this is the last batch, or maybe only maximum one more batch, because the syllabus started in 2016, right? So if you are answering provincial papers or term test papers, you have to answer from 2016 onwards. Before 2016, all syllabus. Before 2016, all syllabus. So now after every 8 years in Sri Lanka, the syllabus change done. So the next syllabus revision, no textbook, only modules. And modules also you have to complete, and you have to get the enough, the minimum number of credits before you apply the oral exam. And in the future they are planning to keep the O level in August and A level in December. You now O level in December, now they are trying to put this in August and most probably from 2024. But anyway, because of the current issues in the country, printing problem and all these papers, and they might extend this to one more year. But 2025 at least you will get the new syllabus. So it's like complete change of the current system. So the school, I mean, now you get 100 marks for the term test paper, so your oral science paper, but in the future they'll give written paper, the oral exam 50% marks, and the rest you have to earn from the school by doing assignment, assessment, practicals, group activities, research, projects and all. So attendance and all the other extra, so they will allocate marks. And then they will get the average and put out of 100. So then beforehand, then you have 50 marks before you face the exam, final exam. And grade 6 to 9 most probably they will make it 70% from the school and 30% the exam. So therefore, I think you don't need to go to much tuition. Then you can, I mean, after school you have many work, right? Because you have to do those assignment, practicals, and the research work and projects. You have to write them, the report after school. Then no time to, actually it's like activity based, more practicals, more skills than just theory knowledge or abstract or content based learning. Okay. Shall I read this? Did you all finish copying down? Then there's an equation by combining all three. Let's see. You can see here the final equation by combining all this. I'll erase the screen. F equals ma. The final equation, derivation of this they will never ask in the exam. This is very, very important. You have to put 3 stars near this. Extremely important. Any oral paper there will be a question from this. Otherwise that will not be the oral science paper. This is the mathematical expression, or this is the equation that we obtain from the Newton's second law. So the relationship between all three, force, mass and the acceleration. So the product of mass and acceleration will be equal to the force. In other words, the previous one we got the equation F equals F is directly proportional to the acceleration is directly proportional to the F over m. Then you can take m into the other side, then it becomes ma is directly proportional to f. So if you make a constant and if it is 1, then it becomes f equals, you can put an equal sign here and put in a constant, then it becomes f equals ma. That's right. But if this derivation they don't ask in the exam, no need to worry. No need to worry. Okay, so right here, what is f here? Unbalanced external force in Newton, or you can write resultant force. So F is not just force, because I'll give one example. You can make a small scale this diagram, everyone. And imagine if there's a force, look at the screen, everyone. This side you apply. Imagine there's an object of 1 kilogram. This object is 1 kilogram. 1 kilogram. And you apply this side 20 Newton force. This side you apply 15 Newton. What is the value we put for F here? So now you want to find the acceleration. We know the unbalanced external force and we know the mass. How to find the acceleration? You can copy down this example if you want in your right book. Example. Now who can tell me the answer? If first you write the equation F equals ma and apply the values. M is 1 kilogram. M is 1 kilogram. I want to find the acceleration. Acceleration equal F over m. You take m into this side, then you make a subject F over m. You take m into the other side, then it becomes f divided by m is equal to a. So what is f here? Who can tell me the answer for f here? F should be unbalanced for the resultant force. That's very, very important to understand. This is the resultant or unbalanced force. unbalanced force, not the balance, unbalanced. Unbalanced force. Any volunteers, what is the unbalanced force? What is the value I should put for F here? I want to calculate the acceleration. This is the formal equation. This is how you can get the question in the exam. Who can tell me the unbalanced force? So what is the value I should put for F in this example? Yes? Yes, Tisavi?
5
Yeah, correct. Very good. Yes, this how your answer is correct. It's 5 Newton. Correct. Very good. How come 5? 20 minus 15. Because the resultant or the net effect is 5 Newton. So it will move into this side with 5 Newton force towards the greater force. Because out of 20 Newton, 15 Newton get cancelled. Out of 20 Newton, 50 Newton gets cancelled. Because they are opposite. Therefore, what is the force left? Only 5 Newton. Out of 20, 15 get cancelled and only 5 Newton. That is the unbalanced force. Therefore, don't write here F equal 20 Newton or F equals 15 Newton. That is completely wrong. And what is the mass of the object? 1 kilogram. So what is the acceleration? What is the acceleration? 5. 5 divided by 1 is 5. What is the unit? ms minus 2. Now the problem some students might ask, sir, how come ms minus 2, which is Newton divided by kilogram? Acceleration measured in meters per square second. How to read this? Meters per square second. ms minus 2 or m over s square. Look at the screen, everyone. That's what I am going to teach next. Okay, let's see. Okay, right, everyone. Unbalanced force, let's see, Newton. Mass, right, mass in kilogram kg, and acceleration in ms minus 2. Acceleration ms minus 2 unit, right? So it's not centimeters per square second, it's meters per square second, right? Acceleration is ms minus 2 SI unit. So what is the SI unit of force? Newton, capital N. What is the fundamental unit? Look at the screen, everyone. F is Newton. F measured in Newton. Then M is kilogram. A is ms minus 2. So Newton is also, you can see this equation. Newton is also equal to what? Newton is also equal to kg ms minus 2. Look at here. Kg ms minus 2 is also equal to Newton, because look at the equation. So I can write here the fundamental unit will be what? Kg ms minus 2. Earlier also I told, because once in the oral paper they asked this. Kg ms minus 2. How do you get this? From the equation. So now you can write here, therefore Newton is also equal to what? Newton is also equal to kg ms minus 2. So please write that if you want separately. SI unit is force, but the fundamental unit of the force is kg ms minus 2. This is very, very important. We can raise questions from this. Now I can give the answer for your question. So you might ask now, sir, how come this is Newton divided by kilogram? How can it become ms minus 2 like magic? It should be Newton divided by kilogram, Newton per kilogram. Actually, when you look at this equation, the units of the final answer should be what? Units of the final answer should be Newton per kilogram, no? Newtons per kilogram. But here you get ms minus 2. Let's see. We'll apply fundamental unit, then you'll get the answer. So I'll write here 5 Newton. Newton is same as kg ms minus 2. I'll write here kg, because Newton is also equal to kg ms minus 2. I'll write here kg ms minus 2 divided by 1 kilogram. F divided by m. Then you get the answer nicely. How? Acceleration is equal to what? Kilogram get cancelled. Look at the screen, everyone. Kilogram get cancelled. What is left? Ms minus 2. So that's why in physics equation the kilogram you can cancel. Then what is the answer left? 5 ms minus 2. But in the exam, no need to do like this. You can do the previous one, accepted. No need to do the fundamental unit and show it in the exam. But for your understanding, I gave this, both the same. Please copy down this. So then imagine, remember, if your method is correct, you don't need to think about the units at the end of the question. If your method is correct, you should get the correct unit. Done? Anyone still copy down? Please raise the hand. So now we discuss how many laws are there? 3 laws. So out of the 3 laws of motion, Newton's laws, we discuss now 2 laws. So the third one is very easy, no calculation. Only from the second law you are getting the calculation. This equation I don't know, F equals m, put 3 stars. Sometimes they can give you the acceleration and the mass and ask you to find the force. Sometimes they will give the force and ask you to find the acceleration. To get this much of force, what should be the acceleration? Or else to get this much of acceleration, what is the force required? Now I am going to link the Newton's laws with the velocity time graph. Unit 2 and unit 4 I am going to combine. Anyone still copy down? Please raise the hand. Shall I raise this? Okay, when you're done, only Vishwa. Others are done, right? Others? Okay, when you're done, Vishwa, please lower your hand. I will, because I want to give you some. Okay, others, keep your writing book ready. The CR book. For physics, you have to use a separate CR book. Because it's not given in your textbook. I'm going to give some extra point, not right. Done. If you want to get a screenshot also, right. Okay. Look at this. Now I am going to draw a velocity time graph. Look at the screen, everyone. Velocity time graph. In this velocity time graph, you also better draw this quickly in your writing book. It take time because there are about 5 minutes only left. Okay. Imagine this velocity time graph. First I'll draw acceleration. Then I'll draw uniform velocity, this velocity time graph. Then I draw deceleration. So label y-axis velocity in ms minus 1, t time in seconds. So I'll put here a, b, c, d. So tell me, this is acceleration. What is called uniform acceleration. If there's an acceleration, it is Newton's first law or second law. This is uniform acceleration. This is uniform velocity. Velocity is constant. This is called uniform velocity. This is uniform deceleration. If there's an acceleration or deceleration, now my first question, A to B under Newton's first law or second law? Who can tell me the answer? A to B, Newton's first law or second law? Newton's first law or second law? Any volunteers? A to B, Newton's first law or second law? There's an acceleration. If there's an acceleration, there must be unbalanced force. So you can write F equals ma for this. How come? Because there's an acceleration. If you know the mass of this, you can find the force. How to find the acceleration? Gradient of the graph. Unit 2, you had done it. So what is this? Newton's second law. Second law. Please draw this, everyone. No need. You can quickly draw this in your writing book or in the theory itself. So this is what? Uniform velocity is what? Uniform velocity means Newton's first law. Newton's first law. Newton's first law. Why? Uniform velocity means forces are balanced. For the velocity to become uniform, forces must be balanced. Is that clear? B to C uniform velocity. Uniform velocity means Newton's first law. What are the two main facts of the Newton's first law? Either at rest or travels with the uniform velocity. So can you write the F equals ma for this? Can't, because F equals ma, because acceleration here 0. No acceleration, no unbalanced force. Acceleration 0. If acceleration 0, F equals ma. If acceleration 0, what is the force? Force also 0. No resultant force. 0 into m is 0. Please, this is very important. So therefore here acceleration 0, velocity is uniform. F equals ma, if a 0, F also 0. Unbalanced force 0. What is uniform deceleration? This one after applying brakes. At point C you apply brakes and slow down and come to rest. So the velocity is 0 here. This is called Newton's second law. If there's an acceleration or deceleration, this is Newton's second law. Newton's second law. Please put an arrow toward this and write Newton's second law. Uniform deceleration C to D in Newton's second law. If there's an acceleration or deceleration, it's applicable to the Newton's second law. So this one you can write F equals ma equation. F equals ma equation. Is that clear? So this is the connection between Newton's laws and the motion graph. Newton's laws and the motion graph. Because you learn Newton's laws under chapter 4 and you learn velocity time graph under unit 2. Unit 2 also physics, unit 4 also physics. So in the exam they can make the fruit salad. You learn them separately, but in the exam they will combine them. In other words, you eat before the exam. In the school you learn unit twice, so chapter by chapter, then it's okay. You will eat the banana separately, pineapple separately, guava separately. But when it comes to the exam, it's like a fruit salad. So in one essay type question, they can combine 2-3 lessons. So within 3 hours, you have to recall all this. Right. So that is called blended learning. Blended learning. And authentic learning. So that's what they are planning to introduce more to the new syllabus. Okay. Right. Shall I erase this? Anyone still copying down? So we can complete the lesson next day. Newton's third law and the momentum only left. So I'll complete that part next day and we can finish the next the next class. We can complete this lesson and do the questions also. So remember, in April we are doing all 4 classes. Next class this next class is on Thursday 14. That day I will not do the class, so I'll put an extra class during holidays. I'll send the date and the time to your WhatsApp, right? Because anyway you are on school holidays, so I'll do an extra class one of the day morning. So I'll let you know. Next Thursday, since many of you are celebrating the new to the class 14th of April 6 p.m. but I'll do a cover up lesson for that. But 21st and 28th you'll be having the class. 21st and 28th you'll be having the class. But anyway, by next month we will be finishing this the first term work, right? Right. Okay, then we'll stop for today. Anyone still copy down? Done? Right. So it's almost 8 o'clock, so we'll stop for today and we'll continue the rest. Next week I'll do a cover up lesson for the 18th, 14th. Yeah. Right. Good night and God bless you.